this is the first lesson in grade 10 mathematics, chapter 1, perimeter. Right, so let's first define what is perimeter. The perimeter of a 2D shape or plane shape is the total length of its boundary. Total length of its boundary. Right. So some shapes you already know how to calculate the perimeter, like square, rectangle, triangle, circle. Those things you already know how to calculate the perimeter, right? So let's just recall those. Right. So first, let's say rectangle. So you have length and width or breadth, right? So the perimeter, let me denote perimeter by P. Then the perimeter is given by what? Total length of its boundary. So there's another L here and another width there, right? So then that is what? 2L plus 2W, right? Then the next shape that you already know is the square. So square length and width are the same, no? L, 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 L. So the perimeter is what? 4 times length of a side. So 4L. Right. Then we have triangle. So triangle has 3 sides. So 3 lengths. Some of these lengths can be the same, right? But we'll take it as different lengths and just write the formula. So you just need to add the 3 lengths. This side length is A, this side length is B, this side length is C. So just add them together. So you have that. Then the other shape that you already know is circle. Right. So circle, the perimeter is also called what? Circumference, right? Perimeter is also called circumference. And what is the formula? You learn it. 2 pi radius. Here I took radius as simple r. So r is radius. So perimeter of a circle is the circumference. Right. So then, right, we know these lengths, right? So these shapes you should know how to calculate the perimeter: rectangle, square, triangle, and circle, right? So in this lesson we are going to mostly concentrate on circles. Okay, mostly going to be concentrating on circles, right? So right, let's do some exercises involving these 4 shapes first of all, before moving on to perimeter of a sector which is part of a circle, right? Right, so let's look at this exercise, right? So we want to find the perimeter of each of the following plane figures, right? Let's look at the first one. It's a rectangle, no? So the first one, length is 20, width is 10. So the perimeter is what? 2 times 20 plus 2 times 10. So you get 40 plus 20, 60 centimeters, because this is also 20, this is 10, right? So then add them all together, right? Then the second shape is what? That's a square. So one side length, we know all four sides are the same. So 4 times 7, which is 28 centimeters, right? Then the third one, right? So this side is 12 and these two sides are also the same length, right? So then this is also 12 centimeters, this is also 12 centimeters. So then this is what? 12 times 3, so 36 centimeters perimeter of the triangle. So this type of triangle is also called a special name. If all three sides have the same length, it is called equilateral triangle, right? Okay, then right, okay, then we have right a shape that has rectangle parts, right? So this one, let's see, right, look, this length is 12, this length is 3, right? This length is 3, then we can figure out this length. Let me label it as x. We need that length. No? What is that length going to be? 12 minus 3, right? Because x plus 3 is equal to 12. No? Is that clear? X plus 3 is going to be 12. So then x is equal to 9 centimeters. So this length we need to figure out, right? Then another length we need to figure out. That is which length? This length also we need to figure out to get the perimeter. So let me erase the red lengths. So we need to figure out this length. Let me label it as y. So we can use what? 3 plus y is going to be equal to this length, 8 centimeters, right? So y plus 3 is going to be equal to 8. So then y is equal to what? Y is equal to 5 centimeters, right? So now let me note those lengths here. So this length is 9, this length is 5, right? Now you can find the perimeter, add all the lengths. So let's start from 8 plus 9 plus 5 plus 3, another 3, then plus 12. So 8, 9, 5, then this 3, then this 3, then finally that 12, right? Okay, so add them all together and you get the perimeter of this shape. So 17, 22, 25, 28, 40 centimeters. This is equal to 40 centimeters, the perimeter, right? Then let's look at fifth shape, that is also a composite shape, right? So then let's see how to figure that one out. Right, this one, it's a little bit tricky but not that hard. Take this length as x, okay, this length as y, right? Wait, no, let me take as x1 and x2. Let me draw this here to make it more clear. Right, we have this shape, right? We have this shape. This is given as 10 centimeters and this length is also given as 10 centimeters, right? Okay, right. We have to find the total length to get the perimeter, total length of the boundary, right? So let me label this length as x1 and this length as x2, the horizontal length, and the vertical length let me label as y1 and y2, right? So then now notice x1 plus x2 is what? If I just move x2 to here, what do you get? Same length as 10 centimeters, no? x1 plus x2 is 10. Similarly, if I move this y1 to here, y1 plus y2 becomes what? That length. y1 plus y2 is also equal to 10. When you add those two lengths, you get 10. x1 plus x2 also you get 10, right? So then we actually don't need individual values of x1, x2 or y1, y2. We don't need to find that. We just need to know what is x1 plus x2 and y1 plus y2. Then we can find the perimeter. So the perimeter is what? 10 plus 10 plus y1 plus y2 plus x1 plus x2. Those are the sides, no? So then this we know is 10, right? This we know is 10 and x1 plus x2 is also 10. So then we can find the perimeter. 10 plus 10, another 10 plus 10, so 40 centimeters, right? So just notice the shape, okay? That's all. It has a square shape, right? So we use that and get the relationship between x1, x2 and y1, y2, right? Then the final one, the circle, right? So circle, the perimeter is the circumference, no? So 2 pi r is what? 7 centimeters. So we'll take pi as 22 over 7. So 7's cancel. 44 centimeters is the perimeter, right? Okay, so right, that is just to recall how to do perimeters of these basic shapes, right? So we'll do one more question that is more difficult than this, right? So let's look at this composite shape, right? We want to find the perimeter of this, right? Okay, so now let's use what we know. This is 4, means this length is 4, right? So we'll mark that is 4, no? So these three lengths are equal, so we know this is 3, so this has to be 3, this has to be 3, right? So those are done, right? So then look, then this length is 6 centimeters, no? Because this is 6, no? Right, so that is also done. So what is the length missing? This one, x. So for that you have to use what? Pythagoras theorem, right? This is a right angle triangle, so we can use what? X squared is going to be equal to what? 3 squared plus 4 squared. So then x squared is equal to 9 plus 16. So x squared is equal to 25. Then square root of x is what? The x squared is what? X, and square root of 25 is 5. So that is 5 centimeters, right? So then you can find the perimeter. So perimeter is what? We'll start from here. 3, 4, another 3, then this 6, then this 3, another 6, then we have x, which we found as 5. So that gives you the total length of the boundary. So that is the perimeter. So what is that? 10 19, 25, 30, 30 centimeters. Right. Okay. Right. So that part is done. Okay. Then in this chapter we are going to introduce sector of a circle and find the perimeter of a sector of a circle next. Right, let's put the topic sector of a circle. Okay, let me draw a circle. Right, then this is the center. Okay, this is center. Let me label it as O. Then from the center, let me draw these two radius. So this is R, this is R. Right, and this angle at the center, let me label it as theta. Let me label it as theta. Right. Okay, then this shaded region is called a sector of a circle. Okay, sector of a circle is the section of a circle that is bounded by the two radius lines and the part of the circumference. Okay, so let me write that down. So this is this one, a part of a circle that is bounded by what? The two radius and the circumference. Part of the circumference is called sector of a circle. This is the sector. Right, so this is the small part. No? This is also called minor sector. Then this big part of the circle that is not shaded is called the major sector. Right, okay, right, okay, that is just additional information. Mainly we are dealing with this. Okay, minor sectors, we are mainly dealing with minor sectors. Right, okay, right, so let me write part of a circle that is bounded by two radii or radius and part of the circumference is called a sector of the circle. Sector of a circle. Right, okay, so right, so this angle at the center can be from 0 to 360. Okay, theta can go from 0 to 360. Okay, angle at the center. Okay, that can go up to 360. 0, it starts from 0 to 360. It can change from 0 to 360. Right, now, right, this part of the circumference is called an arc. Part of the circumference is called an arc. So a sector is bounded by what? Two radii and the arc. Okay, so sector is bounded by an arc and a two radius, right? Okay, now we know what is a sector, right? Okay, now let's see. Next thing we are going to learn is how to find the arc length of this sector. So there's an arc that is connected to the sector. No? We want to find the arc length, that arc length, right? So let's see, there's a formula for that, right? Okay, so let me note down this. The angle at the center, which is theta, can take values from 0 degrees to 360 degrees, right? Okay, right. Now some special types of sectors. This is what? This angle is what? 180 degrees. So this is what? Semicircle. So wait, let me draw a full circle and draw it. That is better. So right, so this angle, so these are the, this is the center, so this is R, this is R, those are the two radius, and the angle is what? Full 180 degrees, right? Then this is what? When the angle at the center is 180 degrees, the sector you get is called what? Semicircle, right? Semicircle. It's called a semicircle, or half of the circle. So semicircle. So these are special types of sectors. Then the other one is what? Other special type you want to know is the quarter circle. So quarter circle is what? We know a total angle is what? 360 degrees, no? So then quarter circle should have what? Angle of 90 degrees at the center. 90 degrees. This is the radius, this is the radius. Then this is our quarter circle. So these are two special sectors, semicircle, and this is quarter circle. Semicircle angle is what? Theta is 180 degrees. Angle at the center is 180 degrees. Quarter circle angle is 90 degrees, right? Okay, right. So then, right. Okay. Now let's see through these two. Let's try to find this length. This is the arc length. No? This is the arc length of this semicircle. This is the arc length of this quarter circle. Let's try to find the lengths of these two arcs. So we know what? Circumference. What's the circumference of a circle? Two pi r, right? 2 pi r. Semicircle is what? Half of that, no? So then this length L for a semicircle, okay, you have to do what? You have to half the circle, right? Half the circumference of a circle. So this is same as what? Let's see, pi r. So you get pi r, no? So this is same as this. Look, 2 pi r is the full circumference. Then we know the total angle of a circle is what? 360 degrees. Semicircle has what? 180 degrees. So that is why you get this 2. You divide by 2. You get what? 180 and 360 cancels, no? And you get what? Half, which gives you 2 pi r times half, which is pi r. So then you can follow the same method to figure out the length of the quarter circle arc. Quarter circle arc. Let's find the quarter circle arc. So we know circumference is 2 pi r. Now we want the length of the quarter circle. Let me label it as LQ, this as LS. LQ, let me label as LQ, this as LS, right? We want that length of that arc, right? So we'll note it down as this. How much of the circumference do we need? 90 degrees over 360, right? Full circle is 360. We want only the 90 degree part. So that gives you a quarter circle, 1 over 4. So you have to do 2 pi r times 1 over 4, or when you simplify, pi r over 2. So, right. So this is the arc length of a semicircle. This is the arc length of a quarter circle, right? So we extend this method to find arc lengths of any type of sector, not just these special sectors. Any type of sector we can find the arc length, right? So next we'll get a formula for that. So let's put the topic arc length of a sector of a circle. Right. So r, and this is radius r, and let's take this angle as theta, and this length is what we want to find. This is the arc, this is the arc. So let me label O, AB. We want to find AB arc length. I label it as L, right? We want to find AB arc length, right? We want to find arc length of this sector, that L distance or L length, right? So we use this same pattern we recognize for semicircle and quarter circle. So arc length, let me denote L as the arc length, okay? L as the arc length. of AB, right? Then this is the formula. L, we know circumference is what, 2 pi r, no? This is how much of the circle, this sector is how much of the circle, total circle is 360 degrees, no? This is how much, theta over that, only theta part is there, no? So this is the formula for finding arc length of a sector. So depending on the angle, you can find the arc length using this, right? So let's do a simple example to see how to apply this rule. Find the arc length, right? So remember, theta is the angle at the center, okay? Angle at the center, angle at the center, right? Okay, let's look at this example. Let's say we have this 45 degrees is the angle, and let's say, what do we want? We'll do radius as 7, radius is 7 centimeters, right? So we want to find the arc length of this sector. Right, so we want to find this length L, right? So apply the formula. L is equal to what? 2 pi, R is what? R is 7 times theta is what? What is the angle at the center? 45 degrees. So 45 over 360. We want to find how much of the circle is this sector, which part of the circle is this. So this is 45 over 360, or 1 over 8, right? So now simplify. 2 times 22 over 7 times 7, 45 over 360 becomes 1 over 8. And now simplify and you get the answer. So 2 and 8 cancels 4, 22 over 4. Or what is the answer? 5.5 centimeters is the arc length, right? Okay, right, then we'll do some more exercises using this formula, right? So let's look at this exercise. We want to find the arc length of each sector given below, right? So let's look at first one. So that one is easy, no? Right, this is a semicircle, no? What's the first thing you need to figure out? What's the radius, right? They have given the diameter, which is 28 centimeters. So then the radius is what? Radius is 14 centimeters. So R is 14 centimeters. So we have that. Now you can find the length of the arc. L 2 pi R. So R is what? r is 14, 180 over 360. We need to find what fraction of the circle this is. No, this is half a circle, so 180 over 360. So now simplify. 2 times 22 over 7 times 14 times half. So what happens? 7, 14 cancels 2 and 2 cancels. So you get 44 centimeters. Right. Then let's look at the second one. Right, second one is a quarter circle, right? This is 90 degrees now, and the area, the radius is 7 centimeters. So what is L? The arc length, this part, that is going to be 2 pi, radius is 7, 45 degrees over 360, right? 45 over 360, that is the fraction of the circle, which is 1 over not 45, 90 degrees. This is 90, no? So this is 90, so 90 over 360. So now simplify. 2 times 22 over 7 times 7 times 1 over 4. Right, 7's cancel, 2 and 4 cancel, and you get 2. 22 over 2, which is 11. So 11 centimeters is the arc length. Right, next look at the next shape. Right, so the radius is 21 centimeters, angle is 120 degrees. Right, so third one, so L, 2 pi, radius is 21 times angle is 120, so 120 over 360. So this is 1/3 of a circle, right? 120 over 360 is 1/3. So let's simplify this. 2 times 22 over 7 times 21 times 1 over 3. So 7 and 21, so 3 and 3 and 3 cancel. 2 times 22, 44 centimeters. So that arc length is 44 centimeters. Right, so now let's look at number 4. So the radius is 3.5 centimeters, angle at the center is 36 degrees. Right, so let's find this one. 2 pi, radius is 3.5, angle is 36, so 36 over 360, which is 1 over 10, right? 1 over 10. So this is 1 over 10 of a circle. So 2 times 22 over 7 times 3.5 times 1 over 10. Right, this cancels with 3.5 and you get 2, and this 2 and this 2 cancels, you get 22 over 10 or 2.2 centimeters. Right, let's look at the next one. Right, so next one, what is the angle? 240 degrees, radius is what? 35 centimeters. Right, so this is the major sector. If you draw a circle, this is the major sector. The bigger part, no, that is called major sector. The smaller part is called the minor sector. So the minor sector would be this section that they haven't drawn. And this arc also, this big arc is called major arc. The small arc that they haven't drawn is called minor arc. Right, that is just additional information. Right, so you don't need to know that to find any of these answers. Right, so L, 2 pi, radius 35, angle is 240 over 360. So we are looking for this length. Okay, this is the length we are looking to find. This is the arc length, this section, this big section, right? So 2 times 22 over 7 times 35, 240 over 360 is what? 2 over 3, right? Simplify, cancel, you get 5, right? You get 5. Can we simplify further? Can we cancel anything else? No. So let's simplify now. 44 times 10, which is 440 over 3. 22 times 2 is 44. 5 times 2 is 10. So 10 times 44 is 440. 440 divided by 3. So this is how much? 146.67 centimeters. Or as a mixed fraction, you can write it as what? 146 and 2/3. Right. Okay. Let's look at the last one. Okay. Now last one is little bit different, right? Because you have to use the correct angle in the last one. So let me draw that. This is given to us. This is 60 degrees. Radius is 20.5 centimeters. And what is the arc length that we need to find? That is this length, this big length. That is this big length, right? So that big length is given by which angle? Not the 60 degree angle. That big length is given by this angle. So this theta we need to know. What is theta? We know the total angle around the point is 360, no? So 360 minus 60. So 300 degrees. So you have to use 300 degrees as your angle, not 60 degrees, okay? So then you can find the length. Length is what? 2 pi, 10.5 is the radius, and 300 over 360, not 60 over 360, okay? We want the bigger length, so then you have to figure out the bigger angle, right? In the previous question it was given, that's why we didn't need to figure out anything else. But this one, the smaller angle is given, so you have to figure out the bigger angle to get the arc length, right? Because they are asking for the major arc, not the minor arc. If we use 360, we get this length, this dotted length, okay? That is not what we want, right? So then simplify. 2 times 22 over 7, 10.5 times 300 over 360 is what? 5 over 6. So this simplifies into what? 2 and 3. 3, and this cancels with this 2. This 3 cancels with this 6. You get 2. Then 22 and 2 cancel, you get 11. So 11 times 5, so 55 centimeters, right? So that arc length is 55 centimeters, right? Okay, so you can do this question using 60 degrees also, but I don't recommend that method, but I will show you that method also. So method 2, So I don't recommend this method, but know this also, using 60 degrees. So then I'm going to find this small length. Let me label that small length as what different letter, S. We'll find S first. S is given by what? 2 pi, radius is 10.5 times what? Times 60 over 360. So 2 times 22 over 7 times 10.5 times 1 over 6. So simplify and you will get, this is going to be what? 11 centimeters, right? So that is S, right? Then L is what? L is the length we want to find. That is going to be the circumference, 2 pi r minus S. Okay, so you have to find the full circumference. So 2 pi times r is what? So pi is 22 over 7. So from that you have to remove S to get the L length, the big arc length. 2 times 22 over 7, 10.5 minus 11, right? Simplify, you get what? 3, 2 cancel. So 66 minus 11, that is the same answer we got now, 55 centimeters. But this is more work rather than using the 300 degrees angle, right? So you can do it like this also, right? Okay, then the next topic is to find the perimeter of a sector. Perimeter of a sector, right? So let me draw a sector of a circle like this, and the angle is theta, then there's radius, and arc length. So what is the perimeter made up of? 2 radius plus the arc length. So remember it like that. Arc length, we have a formula, no? So if you want, you can write it like this also. Perimeter of a sector of a circle is given by 2 radius, this and this, plus length of the arc is given by what? 2 pi r times theta over 360, right? So you should know how to find the perimeter of a circle. So then radius is given, normally radius will be given, so figure out the arc length using the formula for the arc length, and 2r plus arc length is the perimeter of the sector of a circle, right? Okay, we'll do some questions for this, right? Let's look at this example. We want to find the perimeter of this figure. So radius is 21, angle at the center is 120. So we have to figure out what this arc length. So let's find the arc length. Let's find the arc length first. So 2 pi, radius is what? 21, angle is what? 120 over 360. So simplify, 2 times 22 over 7 times 21 times 1/3. So cancel 3, this cancels with this, 44 centimeters. So then the perimeter is what? Perimeter is given by 2r plus L. So 2 times 21 plus the arc length 44, 42 plus 44, which is 86 centimeters. So the perimeter of this sector is 86 centimeters. This 21 plus this 21 plus the L, which is 44, right? Okay, so we'll do a couple of more examples to make it clear, right? Let's look at this example. Perimeter of a sector which is 2/3 of a circle is 260 centimeters. find its radius, right? Okay. 2/3 of a circle, perimeter is given. Perimeter of a sector which is 2/3 of a circle is 260 centimeters. Find its radius. So what do we know? Perimeter is 2 times radius plus the arc length, okay, plus the arc length. So we know now what perimeter we know, which is 260, 2 radius. R and L we don't know, we have to figure it out, right? So L we can figure out, no? Can we figure out L? No. Yeah, we can. 2 pi. We can write an expression for L. Two pi R times 2/3 of a circle, right? So that means for 240 over 360. 2/3 means the angle at the center is 240, but we'll use the simplified form. We want 2/3 of a circle. So L can be written as what? Let's simplify. Let's substitute 22 over 7. 22 over 7 R 2 over 3. So this becomes what? 4488 over 21 R. Right, so then let me label this as 1, this as 2. So now I will substitute L equals 88 over 21 R into 1. Then what do we have? 260 2R. L is what? 88 over 21 R. So now we have to simplify this. So multiply everything by 21. So 260 times 21, 42R plus 88R. So you get 260 times 21, 130R. Right. So don't multiply until you cancel everything, okay? That's why I didn't multiply 260 with 21. I just wrote it as 260 times 21. So now I can cancel. Now I can divide both sides by 130. So I get 2 here. And the radius is what? 42 centimeters. The radius is 42 centimeters, right? This one is little bit more difficult than the normal problems. So here they gave the perimeter and you have to figure out the radius, right? Okay, let's do some more exercises from this section, right? So let's look at this one. Find the angle at the center of the sector when the perimeter is 64 centimeters and radius is 21 centimeters. So let me draw a rough diagram. So angle at the center is what we want to find. We'll label it as theta. Okay, we'll label it as theta. And the radius is given, which is 21. So this is 21 centimeters. This is 21 centimeters. And the arc length is not given, which is L. Right. Then the perimeter is given. Perimeter is what? 64 centimeters. Perimeter is given as 64 centimeters. And perimeter is equal to what? 64 is equal to 2R plus L, right? 2 times 21 plus L. So now we can find the arc length first. L is what? 64 minus 42. So 22 centimeters is the arc length, right? Once we have the arc length, we can figure out the angle at the center using the arc length formula. Okay, so this one we have to first figure out arc length, then use the arc length formula, which is what, 2 pi r theta times 360, and the theta is the unknown now. Okay, angle is what we want to find. So let's write down what we know. Arc length we know 22, 2 times pi we know 22/7, radius we know 21, theta we don't know, we want to find that, and over 360. Right, now simplify. 22 and 22 cancels, 7 and 21 cancels, you get 3. So let me write down what is left now. This side 1, 2 times 3 is 6, so 6 theta over 360. So that is 6 theta equals 360 degrees, or theta equals what, 360 over 6, which is 60 degrees. So angle at the center is 60 degrees. Right, so this one, they gave the perimeter and the radius. We need to figure out what, angle at the center. So to do that, first we needed to figure out arc length, then we can use the arc length formula to figure out the angle at the center. Right, okay. Then the final part of this chapter is to do composite shapes, shapes that include rectangles plus circles, shapes like this. Part of it is rectangle, then you get a circular part like that. So those types of shapes, right? Okay, right. There's no new theory, we just need to combine what we learn and figure out the perimeter or whatever they are asking. Right, we'll do some exercises to those types of questions. Right, so let's look at this example to understand how to find perimeter of compound shapes. So this figure is given. It's made up of what, rectangular part and a semicircle. Rectangle has length 20, breadth 14. So then this diameter of the semicircle is what, 14 centimeters. So then the radius of the semicircle is 7 centimeters. Right, radius of the semicircle is 7 centimeters. Find the perimeter of this figure. Right, so let me quickly draw the shape. Right, this is 20 centimeters, this is 14 centimeters, then this length is also 20 centimeters, no? And this is 14 centimeters, the diameter. So then the radius is 7 centimeters, radius is 7 centimeters. Right, so to find the perimeter, we just need to figure out this arc length of the semicircle. That's it. Right, so let's figure out arc length of the semicircle. L is what, 2 pi, radius is 7, half a circle, 180 over 360, or multiply by half. So 2 times 22/7 times 7 times half. So 7s and the 2's cancel, you get 22 centimeters. This and this cancel, this and this cancel. Right, so then what's the perimeter? This 14, this 20, this L, which is 22, plus this 20. So 34, 56, 76. 76 centimeters is the perimeter. Right, okay, that was an easy compound shape. Next one we'll see something more complicated. Right, let's look at this example. Right, so the figure represents a square lamina. Square, so this is a square lamina, that is important. So square lamina of a side length 15 centimeters. If the shaded sector AGB and the triangular portion GEF are cut out, find the perimeter of the portion BCDFG that is left over. Right. Okay. Right. So we need to find the length of this white part. So we need this length, this length, this length, this length, and this length. So that is BCDFG. So let me write an expression. Okay, let's first find these lengths. Some of these lengths we can quickly find. FD we can easily find. What is FD? Length of a side is 15 and EF is given 15 minus 6, so 9 centimeters. So that we know this is 9. Right. CD we already know, which is 15 centimeters. Right. Okay, then we can figure out this length. AG and AB, they are equal. AG and AB are equal lengths. And how do you figure that out? This length, full length is what? 15. No? This is square lamina. No? GE is 8 centimeters. Then 15 minus 8 gives you AG and AB length, which is 7 centimeters. Right. So this is 7 centimeters. This is 7 centimeters. Right. Then we can figure out BC length now. What is BC length? Total length is 15. From 15 you have to get rid of 7. So BC is 8 centimeters. So this is 8 centimeters. Right. Okay. So then to figure out the perimeter we need what? BG length. This length. BG length and GF length. So we'll first find GF length using the what? This is a right angle triangle. This is a right angle triangle. So EF is 6 centimeters. EG is 8 centimeters. We need to figure out GF length. So then GF squared is equal to what? 8 squared plus 6 squared. So that is what? 64 plus 36. So GF squared is what? 100. So then GF is 10 centimeters. Right. So then we have figured out GF also. That is 10 centimeters. So to find the perimeter of this portion BCDFG, only one section is left. This part BG. That's an arc. So let's find that arc length L. So we have what? This quarter circle. No, we have to use this quarter circle. 90 degrees. No, 90 degrees. ABG. So let me label BG as L, BG length as L. So L is equal to what? 2 pi. This is what? What is the radius? 7. 2 pi times 7 times 90 over 360. So 2 times 22 over 7 times 7 times 1 over 4. Cancel. So 22 over 2 or 11 centimeters. 11 centimeters. So we have the lengths, all the lengths that we need to find the perimeter. Right. So then let's find the perimeter. So is made up of what? FD, then DC length, then BC length, then this arc length 11 which is given by BG, plus finally GF length, right? All of these we have now found. So FD is what? 9 centimeters. DC is what? So this is done. DC is 15. BC is 8 centimeters. BC is 8 centimeters. Then BG 11 and GF 10. 11 plus 10. So add all of them together, you get the perimeter of the portion. Which portion? BCD FG. 24, 32, 43, 53. 53 centimeters. 9, 15, 24, 32, 43, 53 centimeters. Right. Okay. We'll do one more question and in this section. Right. So we need to find the what? The figure shows two sectors of circles of center A, the radius AD and AR respectively. Right. Small sector is AD radius, the bigger sector has AR radius. How much greater is the perimeter of the sector APQR than the perimeter of the shaded region? Right. How much greater is the perimeter of the sector APQR than the perimeter of the shaded region? Right. Okay. So then we'll first find APQR perimeter, right? We'll first do APQR perimeter before doing the shaded region. APQR perimeter is what? AR and BP, which are the radius, both are 7 centimeters. So 7 plus 7 plus the arc length PR we need to find. APQR, right? So this arc length, let's find. This length we need to find. So that is what? Now we have 14 plus L, and L is what? 2 pi, radius is 7, angle is what? 45 degrees. Angle at the center is 45 degrees. So 45 over 360. Right, let's simplify. So 14 plus 2 times 22 over 7 times 7 times 1 over 8. 7's cancel. 2 and 8 cancel. So 22 over 4, which is 5.5. So 14 plus 5.5. So APQR perimeter is 19.5 centimeters, right? Next we need to figure out what? Perimeter of the shaded region, right? So that is BDPR, shaded region, right? Shaded region perimeter. So that is made up of what? BP plus PR plus DR plus BD. Right, BP length we know. This is 3.5 centimeters because this is 3.5 and the total length is 7. So BP length we know, which is 3.5. PR length we found, which is this, the length of this arc, which is 5.5, which we found. For the APQR perimeter we needed to find that. So PR length we know, which is 5.5, and dr length we know, which is 3.5, and the only length missing is bd, that is this small sector, no? So that is the arc length of the sector with radius 3.5, this section. So we need to again use arc length formula. So we need to find BD, which is right. Before that, we'll simplify this. 12.5, and BD is this arc length. So 2 pi, radius is 3.5, angle is 45. So 45 over 360. So simplify 12.5, 2 times 22 over 7 times 3.5 times 1 over 8. So this will cancel 2, this will cancel, you get 22 over 8. So that is what? 22 over 8, 2.75, right? So 12.5 times 2.75. So this gives you 15.25 centimeters. So shaded region perimeter is 15.25. APQR region perimeter is 19.5. What are they asking? How much greater is the perimeter of the sector APQR than the perimeter of the shaded region? So APQR perimeter minus shaded region perimeter. So 19.5 minus 15.25. So 4.25 centimeters greater than. So APQR perimeter is 4.25 centimeters greater than the shaded region perimeter. Right. Okay. So all these exercises that I did, I got from the e-Taksalawa free notes. So you can go to e-Taksalawa and download these exercises. Download chapter 1 note from e-Taksalawa and do the other exercises to practice. Okay, chapter 1 on note in grade 10, under grade 10. Go to grade 10 mathematics under e-Taksalawa website and you can find this chapter 1 note, and then download and do the other exercises. There are more exercises that you can practice with, right? Okay, right, and all those notes are free. Okay, so you can get it for free, right? Okay, right, so we'll end the first lesson here, right?